Haumea, one of the fascinating dwarf planets in our solar system, was officially discovered in 2004. However, its discovery was not a straightforward one and involves a blend of astronomical research, observational technology, and a bit of a dispute over the precise timeline. Haumea's discovery is a remarkable example of modern astronomical endeavors and a reflection of our growing understanding of the distant reaches of the solar system. The early 21st century marked an era of great advancement in the field of astronomy, especially in the study of Trans-Neptunian objects, TNOs, those icy bodies located beyond the orbit of Neptune. Scientists had long suspected the existence of other objects beyond Pluto, following the discovery of Pluto itself in 1930. This was confirmed when, in the late 1990s, the discovery of several small objects in the same region led astronomers to speculate that there were many more undiscovered bodies lying further out in the solar system. One of the most significant advancements was the launch of large, ground-based observatories and the development of powerful telescopes, which allowed astronomers to detect smaller, more distant objects. The Palomar Observatory in California and the Mauna Kea observatories in Hawaii became crucial in the hunt for these objects. As astronomers began focusing on this region, they identified several new objects, including a few that were larger and more distinctive than the rest. It was in this context that Haumea's discovery took place. Haumea's discovery is credited to two independent teams of astronomers working on different continents, with one team led by astronomer Mike Brown and the other by a group led by José Luis Ortiz of the Sierra Nevada Observatory in Spain. Brown's team was conducting a search for TNOs, and on March 7, 2003, they first observed a small, fast-moving object that was later confirmed to be Haumea. However, the object's exact nature wasn't immediately clear. The discovery was significant for a number of reasons. First, Haumea was one of the largest known objects in the Kuiper Belt, the region of icy bodies located beyond the orbit of Neptune. Second, the object's orbit was highly elliptical and unusual compared to the orbits of other Trans-Neptunian objects. Initially, Haumea's nature was debated. Was it a planet, a moon, or just another object among the many others in the Kuiper Belt? This uncertainty delayed the confirmation of its status as a dwarf planet. In the meantime, Ortiz's team in Spain also made an observation of the same object, though they were not initially aware of Brown's team's discovery. Both teams had independent data supporting the idea of a new Trans-Neptunian object, but it wasn't until 2004 that these observations were combined and analyzed. A crucial aspect of Haumea's discovery was the debate over which team could claim the credit. Mike Brown's team at Caltech had been the first to observe the object, but Ortiz's team had also made an important contribution. The two teams engaged in discussions about the timeline of discovery, with each team submitting their observations to the International Astronomical Union, IAU, which would ultimately decide how to classify the object. This led to a series of public discussions in the astronomical community, and the IAU's role in confirming the discovery of Haumea became a central point of contention. Eventually, after reviewing the evidence, the IAU recognized Brown's team as the official discoverers, but both teams were acknowledged for their contributions. However, the controversy surrounding the discovery added a layer of intrigue to Haumea's already fascinating story. Once Haumea was confirmed to be a new TNO, scientists turned their attention to its characteristics. One of the first things that stood out about Haumea was its unique shape. Unlike most other spherical celestial bodies, Haumea is shaped like an elongated ellipsoid, much like a rugby ball. This unusual shape is a result of its rapid rotation. Haumea completes one full rotation on its axis in just about 4 hours, which is incredibly fast compared to other bodies in the solar system. This rapid rotation causes the object to flatten at its poles and bulge at its equator, giving it the elongated shape. This discovery was groundbreaking because it revealed that Haumea was unlike any other known dwarf planet. While most planets and moons are round due to their gravitational forces pulling them into a spherical shape, Haumea's fast spin creates an equilibrium where its rotation forces it to take on this unique shape. Additionally, Haumea's fast rotation affects its internal structure. It suggests that Haumea may have a large, solid core surrounded by a thin layer of ice and rock. This discovery opened up new avenues for understanding the internal composition and dynamics of distant icy bodies in the Kuiper Belt and beyond. Another fascinating aspect of Haumea's discovery came when astronomers identified its two moons, Hiyaka and Namaka, both of which are irregularly shaped. These moons are thought to have been created in a collision event that caused Haumea to break apart, or might have been captured by Haumea's gravity as it was forming. The moons orbit Haumea in a way that suggests it has a significant gravitational influence over them, further confirming its status as a dwarf planet. In addition to its moons, Haumea was found to have a faint ring system, adding another layer of complexity to its characteristics. This discovery was unexpected, as it is relatively rare for objects in the Kuiper Belt to possess rings. The existence of these rings suggests that Haumea may have experienced some sort of impact event that caused debris to accumulate around it, forming a ring structure. The presence of these moons and rings further distinguishes Haumea from other objects in the Kuiper Belt and showcases the diverse variety of bodies in the outer solar system. One of the most significant aspects of Haumea's discovery is its classification as a dwarf planet. Following its identification as a new TNO, the debate began over whether Haumea should be considered a planet. This discussion was particularly relevant after the 2006 redefinition of what constitutes a planet by the International Astronomical Union, IAU, which resulted in Pluto's reclassification as a dwarf planet. Haumea met the necessary criteria to be considered a dwarf planet under the IAU's definition. It is in orbit around the Sun, it has sufficient mass for its self-gravity to pull it into a nearly round shape, despite its elongation, and it has not cleared its orbit of other objects. As such, Haumea was officially classified as a dwarf planet, joining the ranks of other objects like Pluto, Eris, and Makemake. The classification of Haumea as a dwarf planet added to the ongoing debate about the status of Pluto and other similar objects in the Kuiper Belt. Haumea's distinct shape and characteristics, including its high rotational speed, further underscored the diversity of celestial objects in this region and called attention to the complexities of classifying distant objects in the solar system. Since its discovery, Haumea has been the subject of extensive research. Astronomers have continued to study its characteristics using both ground-based telescopes and space-based observatories. The study of Haumea has provided valuable insights into the nature of distant, icy bodies in the solar system, shedding light on the processes that shape the outer reaches of our cosmic neighborhood. One of the ongoing areas of interest is Haumea's composition and its surface features. Observations from telescopes like the Hubble Space Telescope and the Very Large Telescope in Chile have provided more information about Haumea's surface, including its composition of rock and ice. These observations are helping scientists understand the formation of the Kuiper Belt and how large objects in the region have evolved over time. In addition, as new missions are launched to explore the outer solar system, Haumea is likely to be a target for future observations. For instance, NASA's New Horizons mission, which famously flew past Pluto in 2015, has sparked interest in exploring other objects in the Kuiper Belt, including Haumea. Future spacecraft may conduct flybys or other close-up observations to learn more about this intriguing dwarf planet. Haumea's discovery also holds cultural significance. The dwarf planet is named after the Hawaiian goddess of fertility and childbirth, Haumea. This choice of name reflects the Hawaiian heritage of the Mauna Kea observatories, where much of the research on Haumea was conducted. Haumea's name is a reminder of the deep connection between astronomy and culture, as the people of Hawaii have long had a rich tradition of stargazing and understanding the night sky. In addition, Haumea's discovery and classification have sparked public interest in the outer solar system and the ongoing exploration of the Kuiper Belt. As one of the few known dwarf planets in this distant region, Haumea has become a symbol of the vast and largely unexplored territory that lies beyond the known planets of our solar system. Haumea's discovery was a significant milestone in our understanding of the solar system. Its unique characteristics, including its elongated shape, rapid rotation, and fascinating moon system, make it one of the most interesting objects in the Kuiper Belt. The discovery process itself was marked by collaboration and controversy, as multiple teams of astronomers worked independently to confirm its existence. Since its discovery, Haumea has become an important subject of study, providing valuable insights into the nature of distant icy bodies in the outer solar system. As research continues and new missions explore this distant region, Haumea will likely remain a key focus in the ongoing quest to understand the farthest reaches of our cosmic neighborhood.